While the healthcare services are more like the building blocks, the healthcare applications are making use of the healthcare services to deliver more advanced functions. In addition to IoT services, IoT applications deserve closer attention. Basically, it can be noted that services are used to develop applications, whereas applications are directly used by users and patients. So therefore, services are developer-centric, whereas applications user-centric. In addition to applications covered in this section, various gadgets, wearables, and other healthcare devices currently available in the market are discussed. The next subsection just various IoT-based healthcare applications, including both single and clustered condition applications. The first one is glucose level sensing. Diabetes is a group of metabolic diseases in which there are high blood glucose levels over a prolonged period. Blood glucose monitoring reveals individual patterns of blood glucose changes and help in the planning of meals, activities, and medication times. An MIoT configuration method for non-invasive glucose sensing on a real-time basis is proposed in literature 28. In this method, sensors from patients are linked through IPv6 connectivity to relevant healthcare providers. Another application is the electrocardiogram monitoring, which is the ECG monitoring. ECG is the electrical activity of the heart recorded by electrocardiography, include the measurement of the simple heart rate and the determination of the basic rhythms, as well as the diagnosis of multifaceted arrhythmias, myocardial accident, and prolonged QT intervals. The application of the IoT to ECG monitoring has the potential to give maximum information and can be used to its fullest extent. So a number of studies have explicitly discussed IoT-based ECG monitoring. The next application is the blood pressure monitoring. The question of how the combination of a KIT blood pressure meter and a NFC-enabled KIT mobile phone becomes part of a BP monitoring based on the IoT is just in the literature, and there are different literatures looking at different aspects of the blood pressure monitoring. The next application is body temperature monitoring. The body temperature monitoring is an essential part of healthcare services because body temperature is a decisive vital sign in the maintenance of homeostasis, especially during this COVID time. So if your body temperature is abnormal, then definitely you need to go to have some testing. Now, in the literature, this concept is also investigated in different literatures, including literature 28, literature 78, and literature 79. The next application is the oxygen saturation monitoring. Pulse oximetry is suitable for the non-invasive non-stop monitoring of blood oxygen saturation. The integration of IoT with pulse oximetry is useful for technology-driven medical healthcare applications. So this is also investigated in different references here. The next application is rehabilitation system. Because physical medicine and rehabilitation can enhance and restore functional ability and quality of life of those with some physical impairment or disability, they represent a vital branch of medicine. The IoT has the potential to enhance rehabilitation systems in terms of mitigate problems linked to the aging populations and the shortage of health experts. So this topic has been investigated in different references illustrated here. The next application is medication management. The non-compliance problem in medication poses a serious threat to the public health and causes huge financial waste across the world. To address this issue, the IoT offers some promising solutions. So in literature 89 and literature 90, so RFID together with other technologies have been used to try to mitigate this problem. The next application is the wheelchair management. Many researchers have worked on developing smart wheelchairs with full automation for disabled people. The IoT has the potential to accelerate the pace of work. So a healthcare system for wheelchair users based on the IoT technology is proposed in reference 40. The design comes with wireless 40 areas network integrated with various sensors whose functions are tailored to IoT requirements. So a medical support system considering peer-to-peer and IoT technology is implemented in reference 91. And there's another example from the Intel in reference 92. The next application is imminent healthcare solutions. Many other portable medical devices are available, though there is no explicit demonstration of the integration of those devices into IoT network. That is, it is only a matter of time before these devices become embedded with IoT functions. Increasing numbers of medical healthcare applications, devices, and cases have kept pace with the growing demand for IoT-based services across the world. Some healthcare areas whose integration with the IoT appears imminent include hemoglobin detection, peak expiration flow, abnormal cellular growth, cancer treatment, eye disorder, skin infection, and remote surgery. Most devices today are portable diagnosis with conventional connectivity. The next application, which may be quite familiar with you nowadays, is the healthcare solutions using smartphones. Recent years have witnessed the emergence of electronic devices with a smartphone control center, which highlights the rise of smartphone as a driver of the IoT. Various hardware and software products have been designed to make smartphones a versatile healthcare device. An extensive review of healthcare apps for smartphone is presented in reference 95. Based on these references, figure 14 represents a classification diagram of auxiliary apps, which they include diagnostic apps, the drug reference apps, the literature search apps, the medical education apps, the calculator apps, and the clinical communication apps. Smartphones can effectively perform the following healthcare diagnosis and or monitoring, including the detection of asthma, chronic obstructive pulmonary disease, cystic fibrosis, and so on. In addition to its ubiquitous deployment capability and availability for users, there is a great advantage of using smartphones healthcare in terms of providing low-cost solutions, because sometimes you just need to download an app and you don't need to input additional money. However, many challenges remain, including computational complexity, power consumption, and noise environments around smartphones, which should be easy to solve. In addition, there are many healthcare and fitness accessories suitable for smartphones that can help individuals achieve their best shape. For example, we have the Fitbit Flex, which is a fitness tracking wristband. It can help people to keep track of the steps taken, the distance traveled, and calories burned, and so on. So this figure summarizes some typical healthcare apps that can be used on smartphones.